Hello, this is Pre-Calc lesson 97. Today we are going to talk about the ambiguous case. Okay, this is related to solving triangles. Okay, when we're solving a triangle, we have 6 parts, 3 sides, and 3 angles. Okay, now we've done it before where we can solve with the law of sines, the law of cosines, if we know the different angles, we know sides, we know pieces of it. Now, the ambiguous case, is if we have multiple triangles that could be drawn, one triangle that could be drawn, or no triangles that could be drawn based off the information given us. So I'm going to make this little chart. Okay, we solve for our height is either A or B sine of alpha. Alpha is just like a theta. Number of triangles and the figure. Okay, so if one of our sides A is in between 0 and h, the height, then the number of triangles we can draw is 0. Here's our figure. Okay, this is our angle alpha. This is B, right? And this is our h. If A is less than h, it's this little stubby thing here that can't connect. 0 triangles. If A equals h, we have one triangle we can draw, and that triangle looks like this, where this is h and A, this is alpha, that's B. Kind of looks like a right triangle, it's because it can be. Okay. And if h is in between B and A, we have 2 different triangles. Okay, it could look like this. Where this is A, right? This is my H. Or it could also be here. This is A. That's the ambiguous case. Okay, and if A is greater than or equal to B, we have one triangle like this. Okay, so let's do an example. Make this make a little more sense. If we are given A is 40 degrees, little a is 4, and C is 9, we want to draw the triangle and solve for the values of the other sides. Okay, now we first have to determine if we have 1, 2, or no triangles. So here are the possibilities we could get. Right? We could have a right triangle where this is 40 degrees, this is 4, this is 9. We could have a triangle like this where this is 9, this is A, this is 40, which is not really a triangle, but we could have this where this is 40, this is 9, this is A. We could have this case, we have 9, 40, and A, or we could have this case where we have 49A. So the first thing that we have to do is we have to solve for our height. Right? Our height is going to be our opposite side, C sine of 40. Right? If I look here, I don't know why I put 4. This should be A. If I look here to solve for A, the sine of A is opposite over hypotenuse. A in this case is equal to my height. Right, that's how we know it's a right triangle. So we solve this for H and we get 5.79. Now what we see is A, which is 4, is less than 5.79. Therefore, no triangle can exist like this. It would look like this. A would be less than 9, so it wouldn't work. Okay, let's do another example. If we are given A is 27 degrees, little a is 5, B is 7. Okay. We have to figure out what our triangle is going to look like. Are we going to have a triangle? Are we going to have one triangle, two triangles? Okay. So what I'm going to do is I'm going to solve for my height. Height is going to be opposite, which is 7 sine of 27, which gives me 3.18. Now I know that I use B here because I have A and A, right? These two go together, which means I use the opposite side, which is B, as my hypotenuse. Okay, yes, yes. So then if I know that my H is 3.18, A, which is 5, is greater than 3.18 and less than 7. A is in between H and B, which means I have two cases. The ambiguous case is one of them. So I could have a triangle that looks like this. A, B, C. This is 7, this is 27, this is 5. And I use the law of sines to be able to solve for B. So I get 5 over the sine of 27 is 7 over the sine of B. So the sine of B is 7 sine of 27 over 5. B is the inverse sine of that, which gives me 39.46. Now, the 39.46, right, I have to think about this angle, B. It's an obtuse angle, right? That tells me that B is not 39.46 in this triangle. Now what I do, go back to this graph. All students take calculus. 39.46 is this angle here. I also need to look at where sine is positive. It's the second quadrant here. This angle is going to be here, so 180 minus 39.46, which gives me 140.54. That is B, because B is an obtuse angle. Okay. So then I solve for C, 140.54. So then I get that angle C, I do 180 minus 27 minus 140.54 gives me 12.46. So then C over the sine, right, C's here, 12.46 equals, I can use either one, 5 over the sine of 27. And I get that C is 2.38. This is only one case. Let's look at the other case. Okay, I'll do it right here. So this is if our triangle looks like this. Our triangle could also be like this, where this is 27, this is 5, this is 7, this is C. Right? We solve for B in the same way we did here using the law of sines, and we get that B is the 39.46 because we see that this is an acute angle. So that's where we use the 39.46 we get here. Then I solve for C in the same way, C over the sine of this C now, which gives me 113.54. If you don't see how I got that, I did 180 minus 27 minus 39.46. Gave me the 113.54, which is angle C, equals 5 over the sine of 27. And I get that the side C is 10.10. Okay, you have to show both of these answers. You have to show the triangles. You have to show your law of sines. This is the work that you need to put into it. Okay, you can't just write these answers because you have to show which triangle they correspond to. All right, we'll get plenty more practice with this in class tomorrow. So for now, that is all.